All right, guys, we're going to go ahead and do what we're calling in this chapter, section 1.2. I think that's what it says on the notes you have, but 1.2, chapter 1, section 2. And now we're going to get into a little bit of probability, some basic probability stuff. So probability is basically how likely an event is to occur. The probability of an event is measured somewhere between 0 and 1. So 0 being impossible, 1 being certain, right? So 0 correlates to 0%. 1 correlates to 100%. 0.5 would correlate to 50%, right? So there is some of that understanding how to get from fraction to decimal to percent. Does anybody need to see that? Anybody want to go through that just for old time's sake? Or you guys good on that? If I give you the fraction 3 out of 8, you can convert to a percent, or does anybody want to see that? Okay, we'll just get going then. Like I said, kind of fuzzy notes here. So experimental probability, just in case you can't read that, it says it's the number of times the event occurs. So you might just say, we could summarize that as occurrences divided by the number of trials. Again, kind of tough to see, so you might want to add those words if you can't see it. Okay, let's look at some easy examples here. Example 1. Of the 60 vehicles in the teacher's parking lot today, excuse me, 15 are pickup trucks. What's the experimental probability that a vehicle is a pickup truck? And then what's the experimental probability that a vehicle is not a pickup truck? So is and then is not. This is the notation we typically will use. We'll do like P for probability of, and then put the name of our event in here. So I'll just call it probability of truck. Okay. It says right in the prompt that 15 out of 60 were trucks. So that's kind of my probability. Okay. And again, converting to a percent would go, you just take 15 divided by 60. And that's 0.25. So we could say 0.25 or 25%. Okay. So if the probability that it's a truck is 25%, using your logic, what would the probability of anything else be? 75%, right? Like I told you, nice, easy example. If you have any questions, let me know. And just so you know, not that you needed to, but that's an example of what we would call two events that are complementary. Complementary events. They add up to 100%. Covers the whole sample space. All right, you guys look over the next one. It says, softball player got a hit in 20 out of her last 50 times at bat. What's the experimental probability that she gets a hit the next time up? Based on that experiment, based on those trials, what's the probability that she's going to get a hit? All right, so probability of a hit would be 20 out of 50. If I divide there, 20 divided by 50 is 0.4 or 40%. Any questions on that one? Now, in real life, we don't, if you're watching a baseball game, if you're a weird old guy like me who watches baseball on TV, they don't say this player's experimental probability of getting a hit. What do they call that in real life? That's called your batting average in real life. So basically, that's what a batting average kind of tells us. Okay, everybody with me? Questions? All right. So sample space is kind of what we touched on yesterday. Okay, sample space is the set of all possible outcomes of an experiment. When each outcome has the same chance of occurring, those outcomes are called equally likely outcomes. Okay, an easy example to view this, an easy prism to view this under is, or view this through is a dot. Okay, in math books they call it a number cube, but The sample space for the roll of a die, is 1, 2, 3, 4, 5, or 6. Okay, we use set notation, so a little bracket. You could get a 1 or a 2 or a 3, or a 3 or a 4 or a 5 or a 6. Right, those are the possibilities when I roll dice. Okay, are each one of them equally likely? We would say yes. If we have a fair die, yes. Okay. Everybody with me so far? Anybody have any questions? All right, moving on. Okay, so theoretical probability, you can't read any of that. That's a bad image there. Let's just go ahead and add off to the side. The probability of an event happening. In theory, so we haven't run any trials on this one. We would just say that would be the number. What's the word I'm looking for? Number of, let's just say desired outcomes. Desired outcomes. The number of what it's asking about over the number of the whole sample space. Or you could say the total there. Okay. All right, so let's view some examples of some theoretical probability. Okay, in example 3, it says, given a standard number cube, that's a die, what's the theoretical probability of each event, right? So our sample space here, we just talked about that, is 6. Our total is 6. Okay, so how many out of 6 are whatever? Okay, our desired outcome in example A is that we roll an even number, right? What would be the probability that I roll an even without thinking too hard about it? Yeah. That's all right. Anybody have a probability? 3 out of 6 or 50%, right? So if you're not seeing what I mean there, the evens on a die, that set would be 2 and 4 and 6. So 3 out of the 6 numbers we listed earlier are evens, which kind of makes sense logically, right? Since 50% of the numbers are even, 50% of the numbers on a die would be even. Okay. What about the probability of a 7? Am I going to roll a 7? Nope, that's going to be 0, right? There are no 7s in our sample space, so that would just be impossible. C is a little bit trickier. That's one you might just have to list out the sample space, so let's think about that. It says even or a multiple of 3, okay? So evens, we listed those out a second ago, 2, 4, 6. Are there any multiples of 3 that aren't already listed? Is 3 a multiple of 3? Yes, right? So 3 is and 6 is, but 6 is already listed. So we must add 3 here to our set. So that covers 4 out of the 6. Okay, 4 out of 6, if we divide there, is 0.6 repeating, right? So we'll call that about 66.7%. We got a round somewhere, so we'll go about 66.7. You guys are doing a great job participating so far. Appreciate that. Now, I would tell you to go try a couple, but there are some people in here who've been deprived of playing cards in their life, and they don't really know about playing cards, right? So we'll do this one together. You can try example 5. It's more straightforward. Okay. So our total number of cards is 52, right? That's my sample space. Now, again, if you don't know anything about playing cards, then you wouldn't know how many kings are in there. Somebody who does, tell me, how many kings are in a deck of cards? 4, right? 1 for each suit. So there is a 4 or a king in each suit. So that would be 4 out of 52. turn that into a percent. 4 divided by 52 is about, we'll call that 7.7%, 0.076, so 7.7%. All right, here's where I've messed up a couple times. We got to click the right button here. For some reason, when I make these recordings, it's like halfway through, it asks me if I want to jump off, and I've gotten that wrong both times today. So nailed it right there, though. Third time is really charm. All right, so probability of a face card. Anybody know how many total face cards there would be in a deck? 12, that's right. So 4 kings, 4 queens, 4 jacks. So that's 12. Okay, 12 out of 52, that ends up being 12 divided by 52 is about 23.1%. Okay, about 3 times the first thing. Let's not worry about the heart or a 10. That gets a little bit in the weeds. So let's just mark that one out. We'll skip that one together. You can do the same thing with C. We probably won't go over C in example 5 either. So take about 30 seconds and try to do A and B without any of my help. And then I'll go over it. While you're reading it, I'll read it too, just for video's sake. You open a bag of jawbreakers. You have 15 red, 10 orange, 8 green, and 7 purple. What's the theoretical probability of each event? Probability we draw red or orange. Probability of anything that's not green. All right. So first thing you needed to do here was figure out how many are in my sample space. What's my total here? 40. So needed to have that number. Okay. How many are red or orange out of 40? If that was confusing to you, you might note here that orange means to add these 2 sets. So 15 plus 10. If that's obvious, then you don't need to add that symbol. So 25 out of 40. That gives me 0.625 if I divide, so 62.5%. Probability of not green, so you could add up all those that are not green, or you could just take 8 greens away from the total. So 40 minus 8 would be 32. So 32 out of 40, 80%. Very good. So that's 0.8, which equates to 80%. Is everybody with me? Anybody have any questions? All right, so that's the main thing. I'm going to throw one kind of weird, tough example at you. We won't spend a lot of time on it because I don't think it'll come up much, okay? If it does, we can spend more time on it. This will take us back to some review from yesterday too, so it could be good, okay? There's this thing called combinatorics, okay? Honestly, before covering this, I'd never really done any like this, so but it does seem to make sense. So it says when you are simultaneously choosing several things at once, you may need to use combinations to determine the probability of an event. So we're going to skip example 7. We can go ahead and mark that out. And we'll just look at the first 2 here. So we'll mark out C as well. Okay, so what's that mean to select kind of several things at once? Read our prompt here. A student has a personal library of 30 zombie movies and 10 action movies. If a student randomly grabs 6, is that the end of class already? Okay, that's the end of flex. I got you. Okay, so after this, I'll give you all a restroom break, and then we'll come back to flex. Does that work? Obviously, I did this wrong, but thank you guys for being okay with that. All right, so what's the probability given that sample space that we choose 6? Should have just listened to you guys at the beginning, you know. That you choose 6, what are we looking for? 6 zombie movies, okay? We choose just 6, and they're all zombie movies. So here's how you would do that. First of all, we need to know there are 40 in our sample space. So our total is 40. Okay. So usually we're just picking one. That's why this one's quite a bit tougher. So here is what we would do on this one. So probability that we choose 6 zombie movies from a group of 30, right? So how many ways could you do that? So this would be, think back to yesterday, this would be 30C6. 30 choose 6. You might remember seeing that from yesterday, okay? What's the total sample space if we choose 6, okay? That would be 40 choose 6. Okay, and the main reason I wanted to cover this was to show how to type that in one more time, right? So we did that a little bit yesterday, but how do we evaluate those numbers? Okay, so 30C6 on your calculator is under math, probability, and then you want the NCR function. So so number 3 there, and then just type in your numbers, 30 and 6. And we get that 593,775. If you have room, you can write that down. If you're kind of out of room, don't worry too much about it. 593,775. 40C6 is going to be an even bigger number, right? But again, we'll show it again. So that's math over to probability, option 3, if you want a combination. So that'd be 40C6. And that almost seems like a made-up number, doesn't it? 3838380. We're gonna assume it's right though. 3838380. Okay. Now if I divide, then I'll turn them into a percent, and that'll be it. So I'm going to take my 593,775 number divided by the answer. So that's like a copy paste feature. That's a nice thing to be able to do. I did second and the negative key. And I get about 0.15-ish. We'll call it about 15.5%. Like I said, these aren't real big deals, but again, it's good review from yesterday. So you try to do the next one. We'll go over it in about a minute. If you don't have a graphing calculator, just think about how would we set up at least this part, right? How would we set up at least that part? If you have the graphing calculator, go as far through it as you can. I'll review the answer in a minute. What's the probability? They're all action moves. All right, guys, so I'll just show this one and kind of end there. And we'll have some time to kind of do some other stuff, get caught up on Alex and whatnot, learn about flex. All right, so probability that they're all action movies. So whether you had a calculator or not, hopefully you knew how to set this one up, would be 10C6, and the denominator would be the same, 40C6. Any questions about that part? Okay, so we know our denominator from the last one. Our numerator would be 210. Okay, so 210 over that 3838380 number. Okay, and again, we learned something about our calculator here, so just want to show that. So 210 divided by 83880. We'll get a number like that. That's always, if you see that e to the -5th or e to the whatever, That's a scientific notation number. So what this means, and this will be the last thing, is we would take our decimal 5.47 and move that. If you got a -5, that's like 10 to the -5th. So you move it 5 places to the left. So the way you interpret that, just so you know in the future, is a decimal point and then 4 zeros and then a 5. We'll call that. If you didn't know what that meant, we'll call that about 1, 2, 3, 4 zeros and then a 5. Okay, so probably not going to happen, right? If we turn that into a percent, it'd be about 0.005%. Okay. Anyways, that's it. The combinatorics is not a huge part of this lesson. I know it took some time, but more review stuff from yesterday.